Chapter 8 is all about non-right triangles. You really have got to pay attention to the fact, is the triangle a right triangle? Right means you can use Pythagorean theorem and SOHCAHTOA. If it's not a right triangle, or if you can't create a right triangle, then you have to use this information. Okay, so the first thing we'll start with is the unit circle. And I do the unit circle just maybe a little bit different, but this will start out the same. First of all, the unit circle has the center at 0, 0, and the radius is 1. So like wherever you go on your circle, that's why it intersects the x and the y axis at 1 and -1 all the way along. Now, all general circles have the format x squared plus y squared equals r squared. So if the radius is 1, the unit circle is x squared plus y squared equals 1. All right, angle measurement is pretty important. You can never hear that part. First of all angles created for the unit circle start here. This is 0 degrees, and this is our initial side of the angle. Now, if you open it counterclockwise and create an angle going counterclockwise, not anti, we say counter, this is moving in a positive direction. If we were to start and create an angle going clockwise, clockwise is a negative direction, but you always start here. Okay, so if we always start here, and we're going to always talk about the angle created, theta is always on the origin. We open it up from the origin right here. This is always our angle. So what we're going to do is create a right triangle on the unit circle. And if it's always this particular angle, this side over here is my opposite. And this side right here is always my adjacent. Well, rather than A and B, I want you to think in terms of X and Y. We're going to go over the X, come up the Y, and that's where I land on the unit circle. And on my sine, how do we find sine? O over H. Sine is opposite over hypotenuse. In this particular, my sine is represented by the y coordinate over my radius of 1. So that's just y. Cosine from this angle, my adjacent, which always corresponds to x over hypotenuse of 1. Cosine is always the x coordinate. So, big idea. Cosine is always the x coordinate on the unit circle. Sine is always the y coordinate on the unit circle. Okay, so one of the things to keep in mind for sine and cosine, the value of sine and cosine always has to be between -1 and 1, because it's always going to be somewhere on this unit circle. And if cosine is the x, and we're starting with the general x squared plus y squared equals 1 is the basic circle equation. If cosine is the x and sine is the y, doesn't this last bullet point make sense? Instead of x squared, we can write cosine squared. And instead of y squared, we can write sine squared equals 1 on the unit circle. Okay. This is one I'm not real super, I don't use this one very much. First of all, you do need to know, in general, supplementary just means they add up to, some add up to 180. So go ahead and jot this down. We'll use it here and there. Probably the one thing I'm going to show you is notice that sine would have the same value because the y value is the same here and here. It's going to be the same whether you're in the first quadrant or the second quadrant. That's really all this is saying. And cosine is just going to be, because this is going in a negative direction, this is going to be the opposite of cosine. Sine will be the same, cosine will be the opposite. All right, that's section A. Section B is all about area of triangles. We know the area of a triangle is 1/2 base times height. So if you can see probably the key to the base and the height of a triangle, they have to meet at a right angle. So here's my base, here's my height. Your height can be anywhere within or outside of the triangle. The height is literally the highest point away from the base that's creating the right triangle. So here, if this is my base, here's my highest point from the base. So this is the height. So let's look at, say that we have a non-right triangle. What I'm going to do, I'm going to create the height within my triangle, and this is my H. If we know this angle, this is the angle. Now that I've created a right triangle, I can use my SOHCAHTOA. So that's my opposite is the height of the triangle, and my hypotenuse is 8. So sine of 49 equals the height over the hypotenuse. Be very careful with your H because in this case it's meaning the height of the triangle. Because how do we do the area of a right triangle is 1/2 base times height. All right, so I know my base is 10. What's the height? I can calculate the height anytime I have two sides and an included angle because I can create the height using a right triangle, and I can solve for H. My height in this case is 8 sine 49. So we don't have to set this up every time. Anytime you know two sides and the included angle, we can apply this same idea, which is where this area formula comes from. And this area formula is in your formula booklet. So just know how to apply it. It's two sides and the included angle. So this is a good picture. So let's apply that to example 1. Two sides and the included angle, so that actually gives us the right information. Oops. I'm going to use 15 and 11 sine 28. So literally I would just take 0.5 times 15 times 11 times sine of 28. And you should get 38 not degrees. This is area. So if my units are centimeters, it'll be centimeters squared. All right, now this one you did not need as much space for, so you might use some of the space on this one to do the next example. All right, so this time we have 10, 11, and it gives us the area. So let's think of this. Area equals 1/2 AB sine of C. So it gives us the two sides in the area. 50 equals 1/2 10 times 11 sine of C. Now we need to figure out this angle from C. So if I multiply, half of 10 is 5 times 11 gives me 55. Then to get sine of C by itself, divide both sides by 55. So angle C gives me sine inverse, because I'm looking for an angle, of 50 over 55. Now, when you enter this in your calculator, it's going to be 65.4 degrees. Now, here's where you got to be careful. Notice it says the possible measures. When we're talking about sine, and only with sine, it could be in this, and this is where the supplementary angles from section A. This could be my opposite over my hypotenuse. It could either be this angle, which is 65.4, but it could also be this angle here. So whenever it says possible measures, kind of set it up to see if this works. We could also do 180 minus 65.4, because this is my reference angle in the second. And we'll do a lot more with this as we move forward. And that's going to be 114.6. So these are the possible ones. All right. So let me just kind of draw this picture out. If it's the first one, well, we don't know what this side is here, but this is 65.4, and this is 55, and this is 50. Oh, this is going to be, yeah. So I'm going to just go stop with this. Okay, these are your two answers.